Have you ever wondered why objects fall to the ground? You will probably answer, well, yes, of course, it's because of gravity. But is the answer really that simple? Or let me rephrase the question in a different way. Do we really know what gravity is? Gravity was the first fundamental force in nature to be discovered, and it's the one we are most familiar with in our daily life. But do we actually know how it works? The best theory we have to describe gravity is Einstein's theory of general relativity, which was formulated more than 100 years ago in 1915. But physicists know that it cannot be the ultimate theory of gravity. In particular, general relativity is a theory which does not take into account the effects of quantum mechanics, and for this reason, it's said to be a classical theory. These quantum effects become relevant in extreme situations, for instance, inside black holes. So we don't experience them in our daily life, and it's very difficult to get an intuitive idea of what they are. But in any case, a complete theory of gravity must include them. Hence, what we are looking for is a so-called quantum theory of gravity. And this is one of the biggest puzzles that physicists are currently trying to address. Our best candidate is string theory, which provides a unified description of all the fundamental forces and particles existing in nature, including a quantum description of gravity. In this theory, the basic elements of nature are no longer point-like particles, like the electron, for example, as it was previously thought, but one-dimensional strings. And the particles and forces that we know are produced by vibrations of these strings, where different vibrations correspond to different particles. This sounds very promising. However, in the framework of string theory, one can describe a huge number of universes, all with different characteristics, with different laws of physics, and many of these universes do not look at all like the universe we live in. For instance, one could have extra forces or different particles that do not exist in our universe. So one natural question one could ask is any universe possible in string theory? Anything one can think of? And the answer to this question seems to be no. Physicists have been able to identify some requirements that must be satisfied in order to have a universe that is compatible with string theory or with quantum gravity. The universes that are not compatible with quantum gravity are said to be in the swampland, and this field of research is called swampland program. In other words, the swampland program tries to identify the characteristics that a universe must possess in order to be consistent with quantum gravity. This program has been developing very fast in the last years, and it's been showing us that we still have a lot to learn about gravity. So next time that someone asks you what gravity is, remember that the answer might not be that obvious.